Determine the decision variable value which helps in plotting the graph. So we come up with the equation whereby we make x2 the subject. So if we make x2 the subject, we have 1000 minus x1 divided by 2. x2 minus 1000 divided by 2. So we have two equations, equation 1, equation 2. Now this is how we can do that. x1, let x1 be 0. So what is x2? It will be 1000. Let x2 be 0. What is x1? It will be 2000. And this equation, we need to plot it in the graph. I'll show you at a later stage how to do that. We come to the next equation. Let x1 be 0. So what is x1? What is x2? It will be 1500. Let x2 be 0. What is x2? Let x2 be 0. What is x1? x1 will be 1500. Now, when we plot this information in the graph, this is what we will get. This is a sample of the graph using the equation. But now, I want to take you to where you can get the right solution for that question. Now here, we have a problem. Here we have a problem. Now, when you are plotting a graph, this is what you need to do. Identify the y-axis, identify the x-axis. So x1 becomes our x-axis and x2 becomes our y-axis. Now, in our plotting, identify the range. So the range of our plotting as far as x1 is concerned will be 400. So we have 400 all the way to 2000. In our y-axis, we identify our range to be 200. So 200 will be our range. So the highest point will be 1600. Now, once we have done that, we now do the plotting. Our first graph, our first equation is x2 is equals to 1000 minus x1 divided by 2. When you plot this equation, this is the graph. So meaning that x1 is less than. Now in this graph, we are actually looking for what we call feasible point, the point which is within our equation. So the feasible point will be less than. So the upper part will be shaded. So we shade the upper part. That's why we've done the shading. We get the equation, it is below. Come to the second equation. It is 1000 versus 1000. When x1 is 0, x2 is 1000. When x2 is 0, x1 is 1000, x1 is 2000. So this is the equation and this is the line. So we shade the upper part, the lower part becomes our visible point. So already we have two equations. Number 3 equation is x2 is equivalent to 600. So meaning that at this point is 600. So our upper part becomes unwanted part. This is not visible point, so our visible point is below. So in our equation, we already identified the visible point. This is our visible point. Our visible point is within here. So this side is unwanted part. Now what we do, we need to identify the points called corner points. So our corner points are A, B, C, and D, and E. So we have 1, 2, 3, 4, 5. These are what we call corner point. So in our corner point, we just pick each and every corner point, then give the values. So the first corner point is 0, 600. The second corner point is 800, 600. The third corner point, which is here, is 1,500. And then fifth corner point, which is D, is it's giving us in between. You have 1,500 is to 0, and the last one is 0, 0. Now, can we get into the corner points? So our corner points, as far as the graph is concerned, we have corner point A, which is 0, 600, corner point B, which is 800, 600. When you do the equation, corner point C, 1,500, corner point D, 1,200, 0, and then finally corner point E, 0, 0. Now, using the profit or the objective function, 3x plus 3x, whereby we have 3x, which is, we have 3x plus 5x2 is equals to z. Now what we do, we use the corner points to solve the problem. 0 plus 600 times 5, which is 3,000. So 0 plus 3,000 gives us 3,000. 800 times 3, 2,400. 600 times 5, 3,000. 2,400 plus 3,000 gives us 5,000. C, the corner points, 1,000. So 3 times 1,000, 3,000. 5 times 500, 2,500. When you sum, you get 5,500. The next D is 1,200 times 3, you get 3,600 plus 0, 3,600. So the next move is now to get the optimal solution. From the above corner points, we determine the highest value which gives us the optimal solution. Now, the final solution as per the question will be the solution which is giving the maximum profit when you produce 1,000 fruits of basic type and 500 fruits of special types, which gives a maximum profit of 5,500. Now this one, we can see it very clearly. Our maximization equation is here. So this is our maximization equation. So meaning we have solved our problem using graphical method. And that brings us to the end of our problem. Thank you.